Okay, and I see we have another contraption coming up front here.
We do.
Tell us a little bit about this one.
Okay, this robot right here was built and designed with two other tech students. One of my students, Tyler Simos, and Alex from Energy Technology. And what we did here, this was from First Robotics. Okay, in the First Robotics competition we were involved in at Kettering University and at Athens High School. And what the students did is they came together and they built this from a kit, and it was designed to be some type of a soccer type of robot where it had to score goals and defend a goal within another arena of other robots, and they were playing against each other in that sense.
Now you said they designed it from a kit. How did this look compared to some of the other ones you're competing with?
Different, and some were the same. You know, basically, of course, everybody had the same rectangular or square framework. What we noticed is some people had, like we have a narrow wheelbase down here, where some of them were spread out in other directions. Some had units that had cylinders that would extend up and down pneumatically, and you had an air compressor that was actually designed right on board.
Wow.
So again, you're implementing your pneumatics, your electrical, your programming, and all of the mechanical skills that are involved with chain, gear reduction, anything of that sort.
If a parent came up to you and said, hey, Mr. Timmerman, why should my son or daughter look into the Mechatronics programming at Tech, what would you tell them? I
would tell them that it's a very largely growing field. And if they like to use their hands, there's a lot of hands-on practical experience. In the machine industry or manufacturing, it goes way beyond the automotive industry, as we are all ingrained in the Detroit area. We're talking, like we talked earlier, the health field. You have the food services department. All of this stuff that entails robotics, mechanical, programming, all of this stuff has to be made or manufactured in some way, and we need people with high skill levels to be able to go in and program and debug and troubleshoot and build and create these machines. So everywhere from engineering down to the technical person on the floor. We really have a great need for those people.
We're going to take a break, and when we come back, we're going to be right back here in the Mechatronics lab and meet some of the students and see some of the work that they're learning here at St. Clair Tech, so don't go away. Welcome back to Technically Speaking, and as you can see, we're in the Mechatronics lab here at St. Clair County Technical Education Center, and joining me now is Joe Hall. Joe, welcome to the program.
Hi.
What high school do you go to, Joe?
I go to KPAC.
And you are a?
Junior.
Junior, okay. What drew you to Mechatronics? What made you want to get into this field?
I don't know. It's just a feeling that I've had for a while. I mean, when I was in like 6th grade, I've built like robotic arms and stuff like that. I don't know, I guess it's just been a passion.
Well, that's good. What do you hope to do with the skills that you're learning here?
I don't know, just have a good job, good life, retire early, hopefully.
That always sounds good, doesn't it?
Yes.
Yeah, great goals. Well, what are some of the skills that you're learning here in this program?
Well, learning a bunch of skills. Like right here we have fluid power and electrical. We also learn controls engineering and computer science.
And this is really one of those occupations that really crosses a lot of wide areas, doesn't it?
Yes, it does. I mean, it can be from the auto industry to roller coasters, theme parks.
And one of the things we think of a lot of robotics and stuff, but really what you're going to demonstrate to us today is something that we really use every day in our lives. We probably don't even know it, doesn't it?
Yes.
So tell me a little bit what you're going to demonstrate for us today.
Well, this is a pretty simple circuit. Well, this cylinder right here will extend, and it'll show us, yes, it's extended with these lights. And when I press another button, it'll retract, and this red button will tell me, or green button, sorry, will tell me that it's safe, I can work on it.
Okay. So this is really not much different than what we'd see in a factory or any other regular type of application, just simplified, of course, right?
Yes.
Okay. I notice you're not working with a schematic or anything too. Is that normal, or is it because you know what you're doing?
I know what I'm doing.
Okay, good.
This is a fairly simple circuit. Yeah.
Okay. Now is this a pneumatic or a hydraulic type of device here?
This is a pneumatic.
So what's the difference between the two?
Pneumatic is air, and hydraulics is either water or oil, just some sort of liquid.
So, but principle's still the same. Just
yes.
little more force with
They're
the
both
water.
fluid power.
Gotcha. Okay. All right. Well, let's put this thing together and let's see if we can make it work.
All right. All right. First, let's start with the pneumatics.
And of course, the blue tubing is where the air will be coming in and
Yeah.
out of, right? Okay. And like with any kind of circuit, you've got an in and an out for everything to flow around. Okay, good.
Now we gotta get down to our electrical.
Alrighty. Need some cables over here?
Yes,
What do you need?
Give me a couple red.
A couple of red. Okay. Good thing I'm not too colorblind here. Give you a couple of long ones.
Yep.
Here you go.
Yep. Thank you.
And again, you're building this just like an electrical circuit here. What are these boxes for?
Well, this is our power box.
Okay.
We take the power from our outlet, which is over there. And this box right here is just a push button box. Has some lights on it.
Okay, and this is really a simple version of a computer controls you'd have on a machine or
Yes.
device to do whatever task you've set up.
Yes.
Okay,
All right.
good.
Let's see.
And again, the whole idea is to get the arm of that pneumatic device to open and close, is what we're looking to do. Okay. And of course, each valve, each switch that you have all has leads that have to come to the controls.
Yes.
Okay. Now, I also know you're a state champion.
Yes.
For Skills USA, is this a typical type of project that you had to do to win that championship?
Yes. Actually, this is part of a competition a couple years ago.
Oh, okay.
Yes. They released it to the public after the competition's over, and we've been practicing with it.
Good. Okay. How stressful is that competition? Was it a lot of fun?
The stress doesn't get to you until you get there.
Oh,
really.
okay. Sure.
I mean, well, for me, because there's not too many competitors in Michigan.
Okay. And of course, as a result of that, you're going to be representing Tech at the 2010 Skills USA competition, right? Nationally.
Yes.
Okay, good.
Can I get a couple blue?
Couple of blue. Here's one, here's two. There you go.
Thank you.
Now, are these color-coded for a particular reason?
Yes, every single wire has a specific code to it. Like green is always the ground. Right here, blue is our 0 volt.
Okay.
Red our 24 volt reference.
Joe, it looks like you're about ready to set up. Let's see if fire this up, see if it works.
All right.
And that's just turning the air line on, right?
Yep.
Okay. Got the power on.
Yep.
Our red light is on, so that means it's closed, so we better not go over there, right?
Mm-hmm.
All right. Now what's the next step?
Well, press the button, see if it extends.
All right. There we go.
And it does.
Just like you wanted to.
Yep.
Very
and
good.
Green light's on. Retract.
There you go. All right. Very good. Well, way to go.
Yeah.
Wait, thanks for showing us how to do this, and we just wish you well when you go to the Nationals and representing Tech.
All right.
Thanks,
you.
Joe. Thank you very much.